Hello, General Chemistry. Today we are going to talk about types of chemical reactions. We've reviewed what they are, we've reviewed how they're written, we've talked about indications of a chemical reaction, and now we're going to see the different types of chemical reactions, or some of the different types of chemical reactions. Our first type of chemical reaction is a decomposition reaction, and it's not a trick name. It's just like, if a body is decomposing, it's falling apart and breaking into smaller things. A compound breaks down to become two or more smaller compounds or elements, and our example for this that we've been using in class is the decomposition of water. Water, if you put energy into it, usually electricity, you pass electricity through it, you're adding energy. The universe has to invest the energy. So the universe loses the energy, it goes into breaking up this water. But if you do that, you can get oxygen gas and hydrogen gas. So we have one compound breaking down into two smaller elements. And we have a picture of that here. This is an alternate decomposition reaction. We have ammonium dichromate, one thing. It's this powder, crystally brown, light brown powder, and we add energy to that and get that reaction started, and it can break down into three smaller compounds or elements, and one is nitrogen gas. So this we can't really see in the picture because it's just a gas in the air. Water, but because it's so hot, this can turn into water vapor, so it's going to evaporate almost right away, so that's going to be in the air. And chromium 3 oxide, which is what this leftover gray powder stuff is in this reaction. So this is another decomposition reaction. So that's decomposition. Our next reaction type is a synthesis reaction. Two smaller elements or compounds come together to form a larger compound. That is this example. Oxygen gas plus hydrogen gas can give us water and releases energy. So this is a reverse of the previous reaction. Some reactions are reversible, and under the right conditions they can go one way, or you can flip them around and they can go the other way. So in this case, this particular synthesis reaction is the reverse of the previous decomposition reaction. There are other synthesis reactions as well. Let's look at rust. Rust is iron reacting with oxygen to make iron oxide. So iron oxide is a compound coming from the two elements. Iron was the element and oxygen was the element, and now we have iron oxide. So let's go to our next type of reaction. A single replacement reaction. One element replaces another in a compound. So I've color-coded this one to help us see the swapping of partners more easily. We start with the element zinc, and we have the compound hydrochloric acid, HCl here. And so zinc is the red, and the chlorine is the yellow, and the chlorine is the green, and the hydrogen is the yellow. And what happens is the zinc replaces the hydrogen in the compound. So now zinc and chlorine are together to make zinc chloride, and hydrogen has been ousted. Well, what does that look like? Another example of that is this. This is copper and silver nitrate. Silver nitrate is this clear liquid. It's in water, so it's dissolved in water. So we have the silver nitrate dissolved in water, and we have the single copper wire. Just one element. It's just pure copper, single copper wire. Well, when we put this wire into the silver nitrate, the copper replaces the silver in the silver nitrate to give us copper nitrate. And copper nitrate is blue. So you can begin to see the blue liquid forming for the copper nitrate. But what does that mean for the silver? Where does the silver go? Well, the silver just leaves the copper nitrate and becomes regular silver. So everything coating this wire here, that's all pure silver. So we have silver, the copper is becoming, the wire is becoming the silver powder, and then the liquid is becoming copper nitrate, so it's turning blue. So this is a single replacement reaction. Let's go back here. Next, we have a double replacement reaction. In a double replacement reaction, elements or polyatomic ions in compounds switch places. So here I've color-coded it again. We have sulfuric acid plus sodium hydroxide. The hydrogens are red. The sulfate is yellow. The sodium is green, and the hydroxide ion is blue. And as you can see right now, this sodium is going to sort of break up with the hydroxide and join with the sulfate. So we have sodium sulfate. So what happens over here? Well, this hydrogen and these hydroxide are going to come together. Now I wrote it as purple because some of the H is red and some of the H is from the blue. So this is how it comes together, but it makes water. So you have two partners and they each swap. So that's a double replacement reaction. And to get a picture of what that looks like, we actually did double replacement reactions ourselves when we did our when we were mixing our cations and our anions. So when we did our precipitate reactions, these were double replacement reactions. Some of these were double replacement reactions. Finally, the last reaction type, a combustion reaction. A hydrocarbon burns with oxygen to make carbon dioxide and water. This is your classic burning reaction that produces fire. A hydrocarbon is any compound that is made of carbon and hydrogen, and there are lots of different hydrocarbons. So we have a variable number here, X and Y. It can be many different choices for our hydrocarbon, but they will always burn with water. They will always burn with oxygen. Oxygen will always be a reactant, and that will always give us carbon dioxide and water. So a simple picture of that would be a candle burning. Very classic. Both the wick and the wax are hydrocarbons, and then we can see that this creates a water vapor because the water will evaporate right away, and carbon dioxide is released. And anything else that won't combust, that won't be a part of this reaction, will be the ash at the end. So those are our reaction types. I hope this helps. Struggle well.